Here we're looking at how to find common averages, mean, median and mode from data when it is presented in a frequency table. So this is a frequency table, and it's a more compact, clear way of showing a large amount of data. So we'll come back to this one in a minute, but I'll just show you another set of data here. This is just a random set of numbers between 1 and 6. Now this number list is 18 numbers long. It's not too long, but it's already longer than you really would like to look at. And you can imagine if this was twice the size or 10 times the size, just a big list of numbers is not a very good way of presenting the data. And also starts to get more difficult to calculate things like means and medians, because you've got to add up all the numbers for the mean, and that would take quite a long time anyway. And if you imagine this being twice the size or 10 times the size, it would take even longer. But you can arrange this data here in a frequency table. A frequency table is just saying how many of each thing you have. So how frequently does each number appear? So the ones appear 3 times, so the frequency of ones is 3. There's 1 2, there's 5 3s, 4 4s, 1 5 and 4 6s. So those are the frequencies. So you can put that into a table that looks like this. These are the different numbers down here, the different categories of things that we have, and these are how many times those each appear. That's called the frequency. That's what this is as well. This really is quite a long list of numbers. In fact, it's 20 numbers in total. There's 123, there's 4 24s, there's 9 25s. In fact, if I was going to write that out, it would start to look like this. I'm not going to do the whole thing, so it would take too long. That's kind of the reason that they've put in a table, but it would be 23, and then you'd have 24, 24, 24, 24, and then you have 9 25s, and so I'm not going to bother writing that out. But that's what that would look like. That really is quite a long list of data, but it's more compactly presented in the table. So when we work out the mean, we still have to add up all the numbers and divide by how many there are. But the numbers we're adding up are not these numbers, because that's not the data set. That would be like adding these numbers here. But the actual numbers we're trying to find the mean of are these original raw numbers. So the mean will be found by adding all these up and dividing by 18. That can be done on the table, but we have to do one more extra calculation. We have to say, well, this means there's 3 ones. So we would do 3 times 1 in an extra column, and we'd call that usually the frequency times, in this case it would be times the number, often it'll be times a variable like x or something like that. 3 times 1 is 3. Okay, there's 1 2, so that's going to be 2. There's 5 3s, so we do 5 times 3 is 15. That 15 has come from the fact that if I was doing it properly, I'd be adding 5 3s, and that would give me 15. And I'd have 4 4s, 1 5, and 4 6s, and so on. I then add those numbers up, and I divide that by how many there are, which in this case is 18, and that'll give me the mean. Let's do that for this set of data here. You can use a calculator for these just to speed things up, although you might not get a calculator for this in some situations, so make sure you be capable of doing this without a calculator, but we can speed things up right now with one. So we've got 123. Okay, that's just 23. There's 4 24s, that is 96. There are 9 25s, that's 225. There's 3 26s, that's 78. There's 3 27s, and that's 81. And you could call this the sweets times frequency column there. So the total number of sweets is this column added up. Like this 225, it's saying there's 225 sweets here in the 9 bags of 25. Add these up and we get 503. We divide that not by 5. Maybe you can see why 5 is a common mistake here, because there's 5 categories. But we're looking for the number of sweets per bag, the average number of sweets per bag. So we divide this by how many bags there are, which in this case is 20. It says up here. If it didn't say that, you could add the frequency column up, because each one of these numbers represents a bag. The total of that is 20. So the mean, therefore, is going to be 503 shared out between the 20 bags, and it turns out to be 25.15. So that is the mean. The median, Well, again, the median could be worked out from the original list of data by just finding the middle number, the central number. There's a little bit of confusion over the median because it does have a formula which some people try and ignore sometimes, but I think it's quite important. And it's this. Now, what does this mean? N is the number of numbers, the number of things in your data set. So in this case, it would be 18, and in the case of the suites, it would be 20. Plus 1, and then divide by 2. Now, the divide by 2 probably makes sense to you because the median is the middle number. It's halfway along the set of data. Why the plus 1, though? Well, let's look at this data set here. So we've got 18 numbers, and I've actually written them as two groups here in order. So the first 9 are here, and the second 9 are here. Now, where is the middle of that? The middle of it would be here. 3 is not the middle. 3 is actually slightly more towards the start, and 4 is actually slightly more towards the end. In fact, if we look at this more generally here, if I draw out a little diagram of 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 numbers there. And then 10, 11, 12, 13, 14, 15, 16, 17, 18. Another 9 numbers there. This is like a visual description of my set of numbers there. Where is the middle of that set of data? But if you say it's here, not quite, because that's a little bit more towards this end. If you say it's there, the 10th number, again, that's more towards this end. The middle of 18 numbers is actually between those two there. It's kind of like the 9.5 number. Well, that's what this formula is telling you. Take 18, add 1 to get 19, divide that by 2, and in this case, you're going to get 9.5. Now, it's not saying the median is 9.5, it's saying the median term is the 9.5th term. In other words, it's halfway between the 9th and the 10th term. So it's halfway between these two. Now, the 9th term is 3, the 10th term is 4. What's halfway between 3 and 4? 3.5. If you've got an odd set of numbers, then you still do this, but you would find yourself with a specific number at the end. But the plus 1 is basically giving you space to find the median. But the median, the actual middle of this data set, isn't a number in the data set. It's halfway between two. So the plus 1, it gives you the space to locate the median. It's adding that little bit in there to begin with. Okay, so that's where the median would be in a set of data like that. How would you find it from a table? In a very similar way. So we've got 20 numbers. You can imagine these written out in a big list. I started doing that before, didn't I? So it would be like this list here. We'd be trying to find the middle of this list of 20 if I was going to finish it off. Okay, 20. Well, that means we're going to do 20 plus 1 divided by 2. It's going to help us locate where the middle is. So that's going to be 21 divided by 2, 10.5. So the median is not 10.5. It means the median term is the 10.5th term. In other words, it's between the 10th and the 11th term. So where would that be? Well, the first term is here. That's 23. The next 4 numbers are 24. So up to this point, we've got 5 numbers. So again, if it was in the list, we'd be up to here. That's 5 numbers. But we're looking for the 10th and 11th, aren't we? So then the next 9 numbers, well, that's going to take us to the 14th. So doesn't actually matter exactly where it is because clearly the 10th and the 11th number are both in the 25s. They're both going to appear in that group of 9 25s. So either way, the median is going to be 25 because the 10th number and the 11th number, so therefore the 10th and a half number is 25. It appears in that list of 25. The mode is the most common. It's the most frequently occurring number. It's the number with the highest frequency. Now go back to my table here. So let's ignore this column here, but these numbers here. What's the mode here? Now, a very, very common wrong answer is that the mode is 4. And you might be thinking from this set of data, the mode is 3, but it's not. In this case, the most commonly occurring number in the original set of data was 3. There was 5 of those, and if you look at the numbers in list form, it becomes more obvious. There's 5 of them, 4 of them, 4 of them, 3 of them, 1 of them, 1 of them, but there's 5 3s. So 3 is the mode. Very clearly 3 is the mode here. you're looking for the number that has the highest frequency. 3 appears more than anything else. Yes, the number 4 is here, but that's not saying that in the original set of data that 4s are most common. It's just saying there happens to be 4 4s and also 4 6s. But there's 5 3s in the original set of data, so therefore 3 is the mode. The mode, therefore, in this case is 25, because it is the number that appears most. You've always got to visualize these tables as if they were written out as lists, because that's what they are. They are just lists of data, but organized in a table. So the mode is also 25, the most frequently occurring number. So that is how these problems are worked out usually. There's one little twist, though, that you can have to deal with, which is what you can see on the second set of questions. And here's the first example of those. This is a frequency table where there is an interval, a range of numbers. Now, in this case, somebody's asked how long it takes people to get to school. If you ask people that, they're going to give you loads of different answers. If you're measuring it accurately, someone might take 12 minutes, someone might take 13 minutes, someone might take 17 minutes, someone might take 18 minutes. If you're going to write all those out in a table, you have a lot of columns there. Makes more sense to group them up. So they're saying here that 2 people took between 0 and 10 minutes. Now, don't be too confused by this notation here. This just means that the time, t, was greater than 0, but it was less than or including 10. In other words, the time taken was between 0 and 10. And there was 2 people. 8 people took between 10 and 20, 12 between 20 and 30, and so on and so on. We don't actually know how long these 8 people took. They could all have taken 17 minutes, or maybe one of them took 11 minutes, 4 of them took 12 minutes, and so on. We don't know. They're all spread out in this range, but they're definitely in that range. Okay, let's work out an estimate then for the mean. Now, the word estimate is key here, because the previous question, that 25.15, that wasn't an estimate, that was actually the mean, because we had the actual data, the actual numbers. We don't have that in this case because we have numbers grouped into a range. We don't actually know these 8 people's exact time. So we're going to have to make an assumption here. We're going to add an extra column here called the midpoint. We're going to assume that these 2 people both took 5 minutes, because that's halfway between 0 and 10. That's probably not true, but it's the best estimate we've got. If we assume they took 10 minutes, that's going to be an overestimate. If we assume they took 1 minute, that's going to be an underestimate. The best thing to go for is the middle. So we do the midpoints of all of these here. I'll just write these in. Just be careful that they're all actually the same width. These are all 10 apart, so the midpoints are quite easy to find. They follow quite a nice pattern, but that's not always the case. You might get the last one is like a big range of 50, and you've got to be careful finding the correct midpoint there. Okay, so that's our midpoints. Now we're going to say, using a similar method to before, how much time was taken in total, and share that time out between the 30 people in the data set. So 2 people took 5 minutes, we're assuming. Right, well, that's going to be 10 minutes. And I should put another column here, really, shouldn't I? This is going to be the midpoint times frequency. Okay, 8 people took 15 minutes, that's 120. 12 people took 25 minutes, that's 300. 7 people took 35 minutes. Again, that's our estimate, that's 245. And one poor person here took 45 minutes to get to school. So that's 45 minutes. This is the amount of time. So we add this time up, add all those, and we get ourselves 720. We divide it by the number of students, which we're told is 30. We can also find out by adding the frequency up. So we do it down here actually. 720 divided by 30. Actually, that's quite a nice number. It comes out as 24. You will often get decimals in these numbers. In this case, it's not, but don't be put off by a decimal. The mean can be a decimal, by the way. I didn't address that earlier, but that's a perfectly normal thing for the mean to be. It's not saying that any of the sweet bags actually did have 25.15. It's just saying that's the average. In this case, we've got a nice number, 24. Okay, so that's the mean. Just have to add that extra midpoint column, and it's basically the same method. Modal class interval. Well, class interval is just what these things are called, these ranges. So it's a fancy name for these groups, basically. Modal just means the mode. So which group was the most common? It's this 20 to 30. So the answer isn't 25. The answer is 20. Let's use the proper notation here. 30. So that's the answer there. Where are the most people found? The class containing the median, it's the same thing as before. Let's use the median formula. So there's 30 people. We didn't know that, we'd add this up. 30 people. Where's the middle person going to be? 30 plus 1 is 31. Divide by 2. The middle person is the 15th and a half person. So they're halfway between the 15th person and the 16th person. Where is that person going to be? Well, the first 2 are here. Then the next 8 are here, so 10 people so far. Then the next 12, so that's going to be 22 people. So clearly, the 15th and 16th person, they both appear in this group. They're going to be in there somewhere. So the class containing the median is actually the same as the mode, which will usually be the case, to be honest. Not always, but there you go. So that's what you need to know. Now, the last thing here is a bit of an extra technique that is quite rare, but offers a way of finding a more accurate estimate for the median, and it's called linear interpolation. So what does that mean? That sounds quite complicated, but basically it's saying that the median might not be the person who's right in between these numbers here. Now, if we were to say the median is 25, that is a good estimate, but it's probably not exactly right. We can do a better job of finding exactly, or closer to exactly, where that median person would be by taking into account how far into this group of 12 we actually need to go in order to find the 15th person. Right, so I'll show you what I mean by that. I'm just going to draw another diagram with dots here of the data. So the first 2 people are in the first group, and I'm doing that because there's 2 people in the first group there. So that's those 2 people. And then there's 8 people, 4, 5, 6, 7, 8. There's 8 people in the next group, so I'm just going to border that off there. Now we know that the 15th and 16th person appear in this next group here. So I'll just put these 12 in that are here in total. So that's 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. We know the median is here somewhere. I'll just put in the 0 to 10, 10 to 20, and then the 20 to 30. So the 15th and the 16th person, they end up in this group here somewhere. In fact, we can pinpoint it now, can't we? Because that's the second, that's the 10th person, 11th, 12th, 13th, 14th. There's the 15th. So the median is actually there, isn't it? That's the 15th and 16th person. Now, it's pretty close to the middle of the data set, but it's not exactly halfway, is it? It's like slightly more towards the beginning. So we're not going all the way to the center of the data set to find that median. It's kind of at the beginning of this group. But saying it's kind of at the beginning of this group isn't very mathematical. We can be a bit more precise than that. So to get to the 15.5th person, we need to go 5.5 people into this group, because we have 10 people here, and then we need another 5.5 people to get to where we want to be as the median. Now, what fraction of the entire group have we used there? Well, there's 12 in the whole group, and we want to go 5.5 out of that 12 into the group. So I can write that as a fraction. That's the amount of this group we have used to get to the median. Now, how wide is this group in terms of the original data, in terms of the amount of time they took to get to school? Well, it's a group of 10 minutes, 20 to 30. So we're going this far into a data interval that is 10 wide. So we're doing this fraction of 10. And that's going to tell us how many minutes on top of 20 we should add to get to where that median should be in theory. Now this turns out to be 4.6, rounded off slightly. That boundary there is 20, so we're going to add 4.6 to 20 and get 24.6. So that is an estimate for the median using something called linear interpolation, how far into the data set you can go. So a bit more complicated, you probably haven't seen that before, there'll be a question to try that on the set of questions at the end. So have a go at those. All the answers are on there, so do check them. Let me know if you have any questions about it. I'll send you some questions that don't have the answers on this topic, probably tomorrow or later on in the week, or maybe next week, to have a go at to send me. But try the questions with answers now, and ask if you have any questions about that.